I do have more examples here on how to removing the elements from vectors. Note that you cannot simply remove an element from a matrix or it will be no longer a matrix after that. Instead, you can remove an entire row or column from a matrix. Here is a question. How do you know if two matrices are equal? To answer this, first we need to know what we mean by equal here. Two matrices are equal if all corresponding elements are the same. For a smaller matrix, you may do this by inspecting elements one by one. But in general, you need MATLAB to handle this. There is a function for this purpose, which is called isEqual. Please see the example. Most probably you know what a square matrix is. It is any matrix in which the number of columns and rows are the same. Here I wanted to also mention about the main diagonal of a square matrix. If you look at the figure here, you see that it contains all the elements on the diagonal from the upper left to the lower right. Note that this is defined only for square matrices. A special type of a square matrix are the one in which the elements that are not on the main diagonal are all zero. Let's look at the example here. Now how we can obtain the elements on the main diagonal? It is easy. All you need to do is to use diag function as is depicted in the example below. There is another usage for this function, which is creating diagonal matrix out of the vector. If you give the diag function of a vector instead of a matrix, then a diag function creates a diagonal matrix by putting the elements of the vector on the main diagonal. A very common matrix in linear algebra is called identity matrix, which is a special type of diagonal matrix with the main diagonal being the vector of ones. The example shows a 3 by 3 identity matrix. Two more special square matrices. The lower triangle matrix is a special square matrix in which all the elements above the main diagonal are zero. Please see the example below. Note that you can define upper triangle matrix similarly. MATLAB offers two functions that can help converting a given matrix into lower triangular or upper triangular matrix. For example, the function trio converts a given matrix into an upper triangular matrix by replacing all the elements above the main diagonal with zero. Similarly, there is a function TRIL or TRIL, which converts a given matrix into a lower triangular matrix. As the name suggests, a symmetric matrix is a square matrix which is symmetric around the main diagonal. The example below depicts a symmetric matrix.